All right, ladies and gentlemen, we're back. Hopefully everybody's having a good day out there in the YouTube, in the interweb. This is section 1-2. Section 1-2, properties of real numbers. Sorry, man, I'm weird in the mornings. I'm really sorry about that. I should turn the computer around so I should get like a lapel pin, like so that it picks me up a little bit better. Maybe that's really nerdy. All right, properties of real numbers. So what we're going to talk about today is all the different things that we can do with these sets of numbers. Okay, all the different things that we can do, and all of the unique things that we can say about the sets of numbers. For example, we have the identity properties. We have both the additive and multiplicative identities. Hold on. Did I forget to give you guys that? I do have said I got it next to you. Sorry about that. I'm gonna forget in here because I don't usually give guided notes on it. So I'm really sorry. Just say like, hey, did I got notes today? Do we have that? Sometimes I might say that. Welcome. There we go. All right. So we've got the identity properties. Okay. We have both the additive and multiplicative identity. Okay. The additive and multiplicative identity. Basically, what I'm saying here is when I'm talking about the additive identity, I'm saying what can you add to a number to make it the same? What is the additive identity? What number is the additive identity? 0, right? Obviously. If we take 3 plus 0, we get 3, obviously. So the additive identity is technically, to show the property, you would say n plus 0 is n. 0 is the additive identity. Okay? Thinking about the multiplicative identity. What is the multiplicative identity then? 1, right? The multiplicative identity would therefore be 1, because you're asking yourself, how do I keep it the same? What thing do I do that operation with? What value do I do that operation with to make it the same, to not make it do anything? So -5 times 1 is just -5. Or in general terms, that should be moved over a little bit. Oh, there you go. N times 1 is just n. Okay. You will find that not all operations have identities, especially once you get into a little bit higher level math too. Okay, so again, an identity is one that keeps the value the same. Okay? And inverse, and we have both additive and multiplicative. An inverse is whatever you do to get back to the identity. Okay, whatever you do to get back to the identity. That's the definition of an inverse. You can perform that operation to get back to the identity. Or get back to the identity. I said that right. That would be considered the inverse. So what is the additive inverse of 7? What gets us back to 0? -7, right? -7. So if I wanted to generalize this, then I would say if I have n, what's the additive identity of n? -n, right? The opposite of n. The additive, I think it's an additive identity. The additive inverse of any n is the opposite of n. Okay, so let's talk about the multiplicative inverse. Multiplicative inverse. What gets us back to the identity? Now, if I'm talking about the multiplication, the multiplicative inverse, I want to get back to the multiplicative identity, which is 1. I don't want to go back to 0, I want to go back to 1. So what gets us back to 1? What do I multiply by? Mr. Candle?
1/4.
1/4. In this case, 1/4. Right? So if I wanted to generalize that to n, I would say 1 over n, as long as n is non-zero. And if n is 0, then weird things are happening. Because I would have to divide by 0, and that's no good. So the additive identity is 0, the multiplicative identity is 1. The additive inverse gets us back to the additive identity, which is negative n. The multiplicative inverse gets us back to the multiplicative identity, which is 1, right? So it would be 1 over n. 1 over n. It's basically the reciprocal of that value. Okay, let's take a look at these couple examples here. Let's find the additive and multiplicative inverse of this number. Okay, so pretty easy here. What is the additive inverse of 12? What's the additive inverse? Negative 12. Negative 12. Additive inverse would be negative 12. The multiplicative inverse, therefore, would be what? What would that be? 1/12. 1/12. Please don't say negative 1/12. If you say negative 1/12, you're kind of like doing them both at the same time. You know, you're thinking about that whole opposite reciprocal thing. It's not opposite reciprocal, it is just reciprocal for multiplicative inverse. Don't let the fraction confuse you. What is the additive inverse of negative 9/4? Positive 9/4, right? Just 9/4. Okay, what is the multiplicative inverse of negative 9/4? Negative 4/9. Right, negative 4 over 9. That's a 4 on top. Because I'm taking the reciprocal of that value. Don't make it positive. Okay, if you make it positive, it turns, additive inverse. Okay. So that's additive and multiplicative inverses. Let's talk a little bit more about some other properties that we may have. The closure property. Okay, the closure property. The closure property is something that is it's a little weird. Okay, it's a little weird. The only reason it's weird is because it's hard to wrap your mind around a counterexample. Okay. The closure property says that if you've got the sum or product, and I'm only talking about sum and product, if you've got the sum or product of any two real numbers, it's also a real number. Well, that makes sense, right? If I have two real numbers and I add them together, could I get anything other than a real number? No. It has to be a real number. Okay. Like 3 plus 5 is 8. I know that's a really simple. Really, yes, 3 plus 5 is 8. You're correct. But what am I getting at here? I'm saying that, well, if 3 is a real number and 5 is a real number, then therefore, since the closure property holds, 8 must also be a real number, which it is. Okay. Let me show you here how we would define it. Okay. If A is a real and B is a real, then A plus B is a real. Okay. If A is a real and B is a real, then A plus B is an element of real. If A is a real and B is a real, then A multiplied by B is also a real. It's an element of real. Okay. Let's try to think about the closure property in terms of something that it doesn't work with. Okay. Think about the set of all odd numbers. Okay, everybody go with me. Right? Think about the set of all odd numbers. Does the closure property hold for addition? Does the closure property hold for addition? Meaning, if I take odd plus odd, is it odd? No. Right? The closure property does not hold for addition with respect to odd numbers. Okay? If you add two odd numbers, is the answer also an odd? No. So therefore, we can say that the closure property does not hold for that specific example, okay? When we're talking about real numbers, it always holds for real numbers. Okay? We will always get a real number back out again. It's raining. The commutative property. Okay, the commutative property basically says that you can add or multiply numbers in any order. You can add or multiply numbers in any order. Okay, order is the key word there, order. Order. Changing order is the commutative property. So if I have 7 plus 2, that's the same thing as saying 2 plus 7. If I've got 7 times 2, that's the same thing as saying 2 times 7. In terms of just variables here, you can say that a plus b is the same as b plus a, or a times b is the same as b times a. This lets us change order, and it will not change the final value. Okay. Now, this again only applies to addition and multiplication, sums and products. Okay, that's commutative. Notice how the order changed. And I could represent this for more than just one variable. I could say that A times B times C is the same thing as C times A times B, right? I changed the order and it's not going to change the outcome. I could use that for addition as well. The associative property. The associative property says that the sum or product of 3 or more numbers is the same regardless of how you group them. Okay? Regardless of how you group them. Yeah, I like to think about, different groups of people associating with other groups of people, right? You kind of stay in their own little group, right? Okay. The associative property just says that, if you change up the grouping, that you've still got the same amount of people in the room. Okay. If you change up the grouping, you still have the same amount, regardless of the ways that they are grouped. So, for example, I would say 3 plus 4 plus 5, where 3 and 4 are grouped together, is the same as 3 plus 4 plus 5, where 4 and 5 are initially grouped together. I get the same thing in the end. We would all agree. 3 plus 4 is 7, then plus 5 is 12. If I change that up and I say 4 plus 5 is 9, plus 3 then is 12. So I get the same value either way. I can change the grouping and it's not going to change the outcome. Did I change the order? Does it go 3, then 4, then 5? Yes. It did not change the order. 3, 4, 5. 3, 4, 5. A, B, C. A, B, C. I did not change the order there. And again, the same applies for multiplication. And I can change the order in which they are grouped, and then that does not change the final outcome. 3 times 4 is 5. 3 times 4 is 12. Times 5 is 60. 4 times 5 is 20. Times 3 is 60. It does not change the final outcome, regardless of how I group them together initially. Again, I did not change the order. Changing the order would demonstrate the commutative property. Changing the groupings would therefore change the associative property. And the last property that we're going to talk about is the distributive property. The distributive property is one that we know and love. Basically says that if I've got a value, a constant, not even a constant, any value sitting outside of a parenthesis, I can multiply that value in and represent it, or basically distribute it, using the term there, distribute it to both those parts of the sum or difference inside. So this is like saying A quantity B plus C is the same thing as saying A times B plus A times C. Okay? Or in other words, 3 quantity 2 plus 4 is the same thing as saying 3 times 2 plus 3 times 4. You still get the same value either way. Okay? There's the example 2 there on your pages. I don't have it up on my screen here, but it's an example of using mental math to find a 15% tip. This question is not going to be on the quiz on Friday, but I just think this, in my opinion, finding the tip of a bill is a really important life skill. And I always do the distributive property to do that. Okay, just to estimate it. So if I've got $42.20 and I want to find a 15% tip, okay, would you all agree that I can find taking 15% is like taking 10% plus 5%. Would you all agree with that? Right? So all I'm going to do is just kind of round off the cents and say, okay, if I've got $42, I'm going to find 10% of $42, and then I'm going to find 5% of $42. Finding 5% is really easy. Once you find 10%. Okay? How do you find 10% of $42? Move the decimal. So this is $4.20. So 5% is just half of 10%, right? So if 10% is $4.20, what's 5%? $2.10. And then we can add those together. $6.30. Heck, round up, give them $6.50. I mean, 15%, that, that's I try to hit 20% when I can, which is really easy. Then you just find 10%, double it, right? But again, that's just an important life skill that I think you should have. All right, that's all we have for today. I'm going to stop the recording. So long, everybody watching along at home.